So you hear how there was like no bass because they're canceling each other out. Now let's go up to like 45 hertz, which is above the tuning frequency. Tons of bass, right? Okay, let's see what this looks like. All right, now check this out.
Oh yeah, it changes direction.
So then we're gonna go down just a little bit in frequency and find that point at which, you know, the driver, like my hand, didn't have to move very much in order to make the air in the port move a lot. So check this out. Okay, so look at that.
Oh, cool.
Okay, so then we're gonna go up to like a higher frequency where it changes. The driver is doing most of the work and there's very little air coming out of the vent. So check this out. All right, so see how that works?
Oh, interesting.
So sometimes manufacturers will actually enclose both sides of the driver in a chamber that can resonate. So like this chamber down here is bigger and it resonates at a lower frequency, and this one up here resonates at a higher frequency. So they kind of work together, trading off handling different parts of the subwoofer frequency range so that the full range can experience a kind of like resonance and more efficiency. So one of the basic problems with speaker design is that as air moves through the vent and it gets louder and louder, it moves faster, the air can flow either smoothly or it can kind of get disturbed near the edges. There's like turbulence that happens. So you have to create a shape for the air to flow through that keeps the air on the outsides moving as fast as the air in the middle, or else they'll kind of get disrupted. And if they get too disrupted, then the port will actually stop resonating and then the air won't move at all. It'll actually kind of just stand still and be all jumbled up. So they've solved this in a number of ways. So like in this design here, we can see that the wall of the vent is actually curved as it goes back. So it keeps the air flowing very smoothly along this kind of aerodynamic path. With this particular product, because it gets so loud, this company had to design a new opening that's actually shaped like a nozzle or something, almost like a jet engine nozzle. It gets so narrow way back in here. It's counterintuitive because you'd think that that would constrict the airflow too much, but actually they did some math to determine the exact amount of curvature, and it keeps the air flowing very, very smoothly and there's no turbulence. So this cabinet can get very, very loud. I guess that's why they have smart people working at R&D departments.